Hello. Hello.
Hello?
Yeah. Uh, we'll continue with what we were doing yesterday, logarithms. So, have you tried the questions?
Yeah, I
Okay.
as of now I've only gotten far on the first question.
First question you have gotten.
Not exactly gotten, but I've made some progress. So what I did was I used base change formula to say that log, let's just have a base A where log A 15 and log A like
Mhm.
6 is equal to alpha, and log A 18 and log to A 12 is equal to beta.
This is already given to you. No, you have to use these, not some other base.
Oh,
You want to find out this if this is this. So obviously the answers should come in terms of alpha and beta, right?
yeah,
So why will you take a new base? You should not
yeah,
take any new base because you want to use whatever information is here. So first step would be to try to transform this and make it simpler. This is log 5 square 3 into 8. So this is half log 5 3 into 8, which is half log 5 3 plus log 5 8 is 3 log 5 2, right?
yeah.
So you have half log 5 3 plus 3 by 2 log 5 2. This is what you have. Log, this is what the answer should be. Now basically you have to find out this and this in terms of alpha and beta.
Yeah. Wait, log 3 by 5 is like the ratio of 6 by 15.
Okay, but ratio doesn't help us. How does ratio help?
If we factor out 3, then it could help, I guess.
So now think about this and try to convert this. How will you use these information to find out log 5 base 3 and log 2 base 5?
Okay. How can you factor the, like, if you split the base into two quotients, like if we split 6 into 2 and 3, can we advance from that?
You don't have any rule for splitting the thing like this.
Oh,
You have to do, the only thing that you can do is if it was log C AB, then you could split.
okay.
So you should invert it, make it log base. I mean, actually this is fine. Uh, alpha is equal to log 6 15, which is equal to log 6 3 into 5, which is log 6 3 plus log 6 5, right?
Yeah.
Now you can invert it, right?
Yeah.
Log 6 3 is what? 1 by
1.
log 3 6 plus this is 1 by log 5 6,
Yeah.
right?
Yeah.
Now you can, okay, wait 1 second, I've written it wrong. This is, yeah, it is correct only. So this is coming. So now you can split it apart into two parts. 1 by log 3 2 plus log 3 3 is 1, right?
Yeah.
And this is 1 by log 5 2 plus log 5 3, right?
Yeah.
Okay. So equation that you have here is alpha is equal to 1 by 1 plus log 3 2 plus 1 by log 5 2 plus log 5 3. Similarly, find out an equation for beta. Why is this equation useful? Because it has the two things that we need.
Yeah.
We need these
So
two things.
for beta, it would be log 12 6 times 3. It will become log 12 6 and log 12 3, and then you invert it. It becomes 1 by log 6 12 and plus 1 by log 3 12,
Mhm.
which becomes 1 plus log 3 4.
Write down everything and simplify it and then check what is coming finally.
Yeah, okay.
This should come for you, this part. See the steps here.
Yeah.
18 I'm splitting as 9 into 2, and after that I'm just simplifying. Once you get log 12 2, you can invert it, make it log 2 12, and log 12 3 becomes log 3 12 in the denominator. And then I'm splitting this further, right?
Yeah.
So now we have another equation where there is log 2 3 and log 3 2, but actually what I need is log 5 3 and log 5 2. This is what I need.
Right.
So it will be nice if we get all the logs in the base 5, because ultimately what is it I need? I need base 5 logs,
Right.
right? So what you can say is alpha I can write like this: 1 by 1 plus this. I can change the base of log 3 2 and make it base 5 by doing log base 5 2 by log base 5 3, right?
Yeah.
This is the change of base property. Log 3 2 can be written like this, right?
Yeah.
And here we don't need to change anything, it's already in base 5. Log base 5 2 plus log base 5 3, right?
Right.
So the denominator here becomes log base 5 3, and log base 5 3 goes on top, and the common denominator is there. So it becomes log base 5 3 plus 1 by log base 5 3 plus log base 5 2. This is your alpha.
Yeah.
Similarly, now we can convert beta also to base 5. What we need to do is convert each of these two logs into base 5 logs, right?
Yeah.
So what I can say is beta will be equal to 1 by 2 plus, it was log 2 3. So I will write it as log 5 3 by log 5 2, right?
Yeah.
Plus 2 by 1 plus, it was 2 times log 3 2. So that will write 2 times log 5 2 by log 5 3, right?
Yes.
Now take denominators and all, and what you get on top here is log 5 2 by log 2 times log 5 2 plus log 5 3, plus here we'll get log 2 log 5 3 by log 5 3 plus 2 times log 5 2, right?
Yeah.
Common denominator, again you get beta is equal to log 5 2 plus 2 log 5 3 by log 5 3 plus 2 log 5 2. This is your beta, and your alpha was coming as 1 plus log 5 3 by log 5 2 plus log 5 3. These two equations are now two equations, two unknowns. The unknowns are log 5 2 and log 5 3. That is what we need, correct?
Correct.
So if you just simplify it a little bit, you will say beta into log 5 3 plus 2 beta log 5 2 is equal to log 5 2 plus 2 log 5 3. And now take everything on one side, you will get beta minus 2 log 5 3 plus 2 beta minus 1 log 5 2 is equal to 0. This is your first equation. Similarly, you'll get a second equation from here, taking everything on one side, right?
Yeah.
Log 5 2 plus log 5 3 is equal to this. So you'll get log 5 2 into alpha plus alpha minus 1 log 5 3 is equal to 1. This is your second equation, right?
Right.
Now my variables are actually these. So you can call this as x and this as y. You have to solve for x and y. right?
Right.
Are you understanding what we are trying to do?
Yes.
I want x and y in terms of alpha beta, because finally I want to get the answer in terms of log. Answer was coming as log 25/24 was coming as 3/2 log 5/2 plus 1/2 log 5/3. This was what I needed, so that is why I'm doing all this. I'm trying to solve log 5/3 and log 5/2, right?
Yes.
So the way you solve it is multiply this equation by 2 beta minus 1 and this equation by alpha, and then subtract. Like multiply this equation by 2 beta minus 1, multiply this equation by alpha, and you subtract, then log 5/2 will get cancelled. That term is constant, the same term will come, right?
Right.
So you will be able to solve for log 5/3 then, right? There
Yes.
will be an equation involving just log 5/3. Basically, simple elimination will get you a log 5/2 and log 5/3, right?
Yeah.
Then after that, you can put in the values and you'll get the answer. You can do the simplifications later. We will not worry about it now. Do you understand what happened? What we're doing?
Yeah. I'm understanding.
Okay. Then the next question was solve an equation, right?
Yeah.
Equation was this: x plus log 10 1 plus 2 power x is equal to x log 10 5 plus log 10 6. This is an equation. We have to try to solve it. So, okay, think about it, how to do this. Have you tried this before?
No, I haven't tried it.
One common idea when you have a complicated equation is to bring all the x1s on one side, right?
Yes.
Keep the log 10 6 here and bring everything on one side. X minus x log 10 5 plus log 10 1 plus 2 power x is equal to log 10 6. So this equation at least has all the variables on the LHS and constant thing on the RHS. Now, if you can find some way to simplify this, then your question will be done. So what can you do to simplify the LHS? That is what you should think on. Notice that this log you cannot split right now. You understand?
Yes.
Because it is not in product, it is an addition. Addition cannot be split. Don't make the mistake of saying that this is equal to this plus this. That is wrong. Right?
Yeah.
So So you cannot touch this log right now. You can't do anything to it. So all you can work on is this part, no? Right?
Yeah.
So obvious thing to do is take x common. It will come like this. Plus log 10, 1 plus 2 power x, right?
Yeah.
Can I write this not as a difference but as one logarithm? One can be what? One can be written as log 10, 10, right?
Yeah.
So if it was log 10, 10 minus log 10, 5, you can write it as one term, right?
Yes.
Because I'm making it the same base so that I can, instead of writing two terms, I'll have one term. So you can say it is x log 10, 10 by 5, so 2, right? Right.
Yes.
So this is what I have so far. At least this is better than this simpler. Now, can we combine these two logs?
No. Yes, we can.
Yes, we can, because we can write log, this part we can write log 10 2 power x, right?
Yes.
Plus this part we can write log 10 1 plus 2 power x. So we can, instead of writing 2, we can write 1. We can say log 10 2 power x multiplied by 1 plus 2 power x, right?
Yes.
So the LHS has now become one single term. This is the term, right?
Yeah.
That is equal to log 10 6 on the RHS, correct?
Correct.
Now it is obviously the bases are same, so we can just directly say 2 power x into 1 plus 2 power x is equal to 6, right?
Yeah.
And this is a simple equation which can be solved. Obviously x is equal to 1 is a root. Or you can do it properly also, you can do it 2 power x whole square plus 2 power x minus 6 is equal to 0, right?
Yeah.
So if you take 2 power x as t, this is t square plus t minus 6 is equal to 0. It can be factorized
Yes.
as t minus 2 and t plus 3 is equal to 0, right?
Yeah.
So t can either be 2 or minus 3, but t is 2 power x. So 2 power x cannot be negative. So 2 power x has to be 2 only. It cannot be minus 3. So you're getting x is equal to 1 is a solution, right?
Yeah.
And there is no other solution because 2 power x cannot be minus 3. And it was a quadratic, right?
Yes.
You understood how we have done this.
Yeah, I understood how we did it.
The series of steps, we took all the variable terms on one side. Then we thought about what to do to simplify it. We want to ultimately simplify it to look as small as possible, one term ideally. So we did this, and then we can write this as log 10 10 minus log 10 5. That will become log 10 2. And then we'll combine the two log 10 terms. It will become one log 10 thing. And this side is also a log 10. So after that, we just compare and get solve the equation. Correct?
Yeah. Okay. Can you give me a couple minutes just to write it down, please?
Hmm.
Okay, I'm done.
The next question was the system of equations, right?
Yeah.
Okay. So the question is 5 times log yx plus log xy is equal to 26, and the other one was xy is equal to 64, and you have to solve for x and y. So try it now.
Well, you can divide by 5 on both sides, I guess. Just to start off, I guess.
Divide by 5.
Yeah, because 5 times log yx plus log xy equal to 26. Right?
Okay, that is not necessary. If you can do it, but that is not very useful. Doesn't help us too much, right?
Yeah, sorry.
So that is obvious. What else can you do?
Okay, if we, let's say we invert like, make the reciprocal of log yx. It becomes log xy. No,
Hmm.
that's not right.
Yeah, that is true. It becomes that.
But that's not what I wanted actually. I wanted to make it like with a common base xy so that we could apply like the fact that it's 64. But that's not okay. Oh, I understand. One, if we put one of the logs as x, like z, sorry, not x, z, the
Mhm.
other one's the reciprocal of the other one. So it's z plus 1 by z. So it becomes z
Mhm.
square plus 1 by z is equal to 26 by 5. And then we can just solve the quadratic.
Mhm. Now solve it.
Okay.
Z plus 1 by Z is 26 by 5. So you can just solve the quadratic is equal to Z square plus 1 by Z. So 5 into this is
Yeah.
equal to 26Z. 5Z square minus 26Z plus 5 is equal to 0. 5Z square minus 25Z minus Z plus 5 is equal to 0. 5Z, Z minus 5 minus 1, Z minus 5. So you can get Z is equal to either 1 by 5 or 1. So if Z is 1 by 5, the other one will be 5, right? So we have
Yes.
log xy is equal to 5. Let's say this is Z, and you have xy is equal to 64. That is one possibility. The other possibility is log xy is equal to 1 by 5 and xy is equal to 64, right?
Yeah.
These are the two options. So here it should be easy to do now, because what you can do here is put y is equal to 64 by x, right?
Yeah.
And put this in the first one. So you will say log x 64 by x is equal to 5, right?
Yeah.
So this can be written as log x 64 minus log x is equal to 5. So log x 64 is equal to 1 plus 5. This is 1. So 6, right?
Yeah.
Therefore, x power 6 is 64, and the solution of that is simple: x is equal to 2, right?
Yeah.
You understand now how you're solving.
Yes, I'm understanding.
You're just taking one equation, instead of having two variables, now I have one variable, right? And if we get x is equal to 2, then y is equal to 32. So x and y can be 2 and 32. If you use this one, you will get 32 and 2, right? Like they can be interchanged, right?
Yeah.
So the other possibility is 32 and 2 for x and y. Correct.
Yeah.
Okay. Um,
I'll give me a minute. I haven't finished writing it down yet.
hmm. You've written down.
Wait. If it's for the situation when log xy is equal to 1 by 5, I'm getting that log x to the x64 is equal to 6 by 5.
Log xy is 1 by 5, then you should.
Wait, never mind. I got it. So,
It will come the same thing that I've written.
okay, I finished. Now we can go to the next question. Question 4, which is find all x such that log 1/2 x is greater than log 1/3 x.
Log find x such that correct. So yeah, so think about it. You try it for some time, then we'll discuss if you cannot get it.
Okay.
The base is a fraction, so you have to think about when it is positive and stuff, right? Like it's slightly different when the base is less than 1. So that is what you have to think about. Or you can convert. One more idea could be to convert both of them in the same base, if possible. Right?
Right. But when log 1/2 x is negative, x is like it's not a fraction, I would say. I mean, if like log 1/2 x is not an integer, it's like it's something like
If
5 and
x
a
is
half.
greater than 1, then it will be
No, it's greater.
negative.
Yeah, it's greater than 1. an idea I got was that when log 1/2 x can be written as log 1/3 x by log 1/3 1/2. That's not a very good one, but
Yeah, you can do that. You can write 1/3 x by log 1/3 1/2. If this is greater than this, so just bring it on one side and try to simplify. 1/3 x by log 1/3 1/2 minus log 1/3 x should be greater than 0, right?
yeah.
So take log 1/3 x common and you have 1 by log 1/3 1/2 minus 1 is greater than 0. So this is a constant thing. So first figure out whether this is positive or negative, right?
Yeah.
So this is basically log 1/2 of 1/3 minus 1, right?
Yeah.
Figure out the sign of this, and depending on that, you will know the sign of this, right? For this to be true.
Well, 1/3 is less than 1/2, and whenever 1/2 is raised to a positive power, it decreases since you're multiplying by a fraction. So I think it's positive. Not sure.
Be sure, think about it, take some examples, and realize what has to happen.
Hmm.
You can take some example numbers and figure out what should happen. No?
Yeah. Okay. I'm sure that
Hmm.
1/2 1/3 is positive, and it's
Hmm.
greater than 1.
Hmm. This part is greater than 1, right?
Yeah.
Because only if you raise it to greater than 1 power, then only you will get a smaller than itself number here, right?
Yeah.
Like half power 2 is coming out to be smaller, right?
Hmm.
So in order to get a smaller than itself number, you have to raise it to a greater than 1 power. This is greater than 1, so this is positive. So then this must be positive, right?
Yeah.
So for that to be positive, x should be, if this has to be positive, x should be,
Less than 1/3.
no,
I mean, less than 1.
less than 1,
Right.
not less than 1/3. For less than 1/3, you are saying that x is greater than 1,
Oh, okay.
right?
Yeah.
I mean, no. If you say that 0 is less than x is less than 1/3, then you are solving the inequality log 1/3 x is greater than 1, right?
Yeah.
You have to make it positive. You don't have to make it big. You just have to make
So
it
it only
positive.
needs to be between 0 and 1.
Yeah. Between
Okay. Yeah.
0 and 1, if your base is between 0 and 1, log will be positive if your x is also between 0 and 1.
Right.
And if you go beyond x is greater than 1, log will become negative.
Yeah.
Okay.
Yes.
Next one is which one?
Okay. It's solve for xy. Log 2xy is equal to 5
Hmm.
and log
Uh,
1/2 x by y is equal to 1.
Okay. Log 2x. Okay. So similar method like we did earlier. So try doing it. 1/2 x by y is equal to 1.
This situation is a bit different, but yeah. Okay, so it's log 2x plus log 2y is equal to 5. And log 1/2 x minus log 1/2 y is equal to 1.
Hmm.
Okay, focus. A point to notice here is that log at the two different bases are inverses of each other,
Hmm.
which is so 1/2 x minus 1/2 y.
Hmm.
So the answers to those questions will be opposite of each other, like in terms of negative, positive type of like opposite.
Maybe.
Yeah, maybe, but
We don't
maybe.
know that right now. Uh, right now, it's not clear. The answers will be.
Hmm.
You are saying what? Answers will be what of each other?
I mean, since the bases are like reciprocal, I said there'll be like I think additive inverses of each other.
That is just that is an assumption. We don't know right now.
Oh, you don't know. It can't be always certain. Okay.
Maybe it is. I don't know. Like
Yeah,
by
we don't know.
looking at the equation, you cannot figure that out immediately.
But I guess the only thing I can get as far as for now is log 2x plus log 2y, like 2y,
Hmm.
is equal to 5, and log 1/2 x minus log 1/2 y is equal to 1.
Hmm. Yeah. So ideally, you should convert that 1/2 one also in a log 2 one, right? Like, can you change the base and make this the second log into log 2? So everything will be log 2, right? You can write it as log 2 x by
Yeah,
y by
okay.
log 2 half, right?
Yeah, which is -1.
This is -1, and this comes here, so you get log 2 x by y is equal to -1,
Wow.
right?
So that means x by y is 1 by half.
Huh. Or you split it apart just like you split this one apart. You get log 2x plus log 2y, here is 5, and here you get log 2x minus log 2y is equal to
And you can just do like, wait, no, I can't
-1.
do
Just
that.
add it.
Oh, yeah, just add it.
2 log 2x is equal to 4. Log 2x
No.
is equal to 2.
X is 4,
Hmm.
and
And this
y is
one,
8. Y is 8.
if this is 4, then this one will be
8.
1, no? So log y is 2,
No,
no?
log 2x is equal to 2. Not x is equal to.
Log
Not
2x is
log
equal to 2. So
log 2x is equal to 2, not log x is equal to 4, but not log 2x. 2x is equal to 2. So log 2y is equal to 3. So y is equal to 8.
oh yeah. So this is 3. So y is equal to 8. Yeah. So this is one possibility. X is 4, y is 8. Is there any other possibility?
It says solve for xy, not find all x. So
I
I
mean,
think we solve.
solve for xy means find all roots.
Oh,
So not just be like I will not find the others. So it is possible that uh, one second. Like here, -4 and -8 will also be possible, no? Because -4 into -8 is 32. Again, it will fit, and this will also fit, right?
yeah. I mean, sorry. Yes, but the thing that's irking me that when you split it apart, log 2 minus 4 is
Mm-hmm.
equal to 1 yeah 1/2, right? And log 2 y is equal to negative, it is equal to 1/3, which doesn't add up to 5. So I don't
What?
know.
What are you saying? Which one?
If x is equal to -4, then um like log
Um,
2x will be equal to one
no,
half.
you cannot. The problem is that you cannot split it like this. This is not correct. If you have log 2xy, you have to write it as log 2 mod x plus log 2 mod y, because
Oh,
there is,
absolutely, I do.
because this is not defined. If you have -4 and -8, then obviously it doesn't make sense only. Log 2 -4 is not defined, right?
Okay, then that works too. I remain down.
Log 2 -4 is not defined. No, -4 cannot come there, right?
Yeah, okay, that should have been sense. Yeah, that makes sense actually.
So you have to actually, the formulas are slightly different. The real formulas are like this: log a xy is equal to actually log a mod x plus log a mod y. And similarly, log a x by y is equal to log a mod x minus log a mod y. Okay. So because
So
notice here, if you don't take mods, you will lose out on the other solution. The other solution is -4 -8.
yeah, that makes sense actually.
So you should put the mod there. Then,
So we've solved this question, I suppose.
yeah. Then the next one was what? Next one was another system of equations, right? No, no. Next one was
Find value. It's telescoping question.
ninth, the log 10 tan 1, that one, right?
Yeah.
Okay.
I, this sounded like something. They sound like a series I would read in hall at night. But
And finally, it is still log 10 tan 89, right?
mm.
Hmm. Okay.
Is there any rule for multiplying? Because I don't see it.
Focus on what it is, tan 1 and all. No, tan 1, you
And
can
one.
figure out what that is supposed to be. Tan 1 and tan 89.
Just sum to 90 is all I'm getting. And 189. Yeah, so basically the 89 terms. That's pretty
Tan
accurate.
89 is what? Complementary to 1. No, 89 degrees complementary to 1
Yeah, that's
degree.
what I said. They sum to 90.
Yeah, so it is
Oh, it's 90 minus theta. So it's negative tan theta.
no, tan 90 minus theta is cot theta.
Cot theta. Okay, cot theta. Yeah. Okay, put that.
right?
Yeah. That means it becomes cot 89 degrees.
It becomes cot 1 degree, no? Log 10 cot 1 degree.
Oh yeah, okay. I was actually talking about log 10, tan 1 degree, but yeah, makes sense. Okay, then what is cot times tan? Cot theta is 1 by tan theta.
Hmm.
That means it just becomes 1, but then the log addition is kind of.
Oh, actually, the whole thing is 0, no? Why? Because there
Log
is
10 tan 1. I
45.
mean, just 1, not tan 1. 1. Oh, yeah, makes sense.
No, I'm saying there is a middle term which is 45, right?
Huh, yeah, which is doesn't have a friend.
But 40 tan 45 is how much?
Sine for it's 1.
Log tan 1 will be what? Log 10 1.
It's 0.
The overall product will be
0.
right. So you don't need to do anything here, actually.
Yeah, that makes sense. Okay.
You don't have to worry about the other ones because there is a middle term that is 0. No?
That cancels everything out.
Yeah. Right. So you don't need to actually do anything basically.
Yeah, that makes sense. It was a trick question.
Yeah. Then the next one was which one?
Number 7. Log 2x minus 8 log x to x squared 2 is equal to 3.
Log 2x minus 8 log x squared 3 is x squared 2 is equal to 3. Solve for x.
Yeah, that was it.
Okay. So ideally, if you want to solve for x, I should have one similar base everywhere, right? I
Right,
don't
okay.
want a base where there is one base 2 and one base x squared, right?
Well, the 8 log x2 becomes 4 log x squared 2. Because of the x squared in the base, right?
That is true. So you have log 2x minus 4 log x2.
And then they're just recipicals of each other, and then the question is just solved. It's simple.
You can say z minus 4 by z is equal to 3, right?
And then becomes a quadratic, and we're pretty much done.
So you'll get something like this: z square minus 3z minus 4. Okay, after that you can solve, no?
Yeah, I know this one algebra.
Yeah, so this is easy only, no issues. Just try to convert it to same base, right?
Right.
Okay. The next one was which one?
Number 8. Okay, this one's like lots of signs. Okay, so it's whole. Okay, you need to draw a big square root, and then underneath it's like log 1/2.
Find all
X
real
by X.
values of x.
Yeah, okay. Yeah. Okay.
Find all real values of x such that root over log base half x by x square minus 1 is real.
That's right.
So, okay. So something under a root, something under a square root is real if and only if the thing under the square root must be
Positive.
So the thing under the square
Or
root
even
here,
not positive, it's not negative. Because it can be 0.
so it can be greater than equal to 0. Like this basically means
Yeah.
that this should be greater than equal to 0, right?
Yep. Yeah, that makes sense.
And now normally if I had log 2 something greater than equal to 0, then I would say this something should be greater than equal to 2 power 0, right?
Yes.
But now my thing is a fraction, right? So then the inequality sign is reversed. So this something should be less than equal to this power 0, right?
Yeah.
That is the thing that you have to be careful about. When the base is less than 1, positive will happen when the thing is less than 1, right?
Yeah.
Correct. So see,
Yeah.
this thing, which is x by x square minus 1, should be less than equal to half power 0 or 1, right?
Yeah.
So now you just have to solve this, right? What values of x will we need so that this thing is less than 1, right? So how would you solve it? This algebra part.
Okay. I know that multiplying both sides by x squared minus 1 might not be the best option because you can leave some options out.
Yeah, so don't multiply, never cross multiply in inequalities, because we don't know what is the sign of this, right?
Yeah.
The
That's
reason for not cross multiplying is I don't know whether x square minus 1 is positive or negative. If it is positive, then cross multiplication doesn't change the inequality, but if it is negative, it
okay.
reverses, right?
I'll do an easier option. Subtract both sides by minus 1.
So we have to do this, and it will be x square minus 1, x minus x square plus 1 is less than equal to 0.
Then you can't multiply. You can multiply by minus 1 on both sides this time, right?
X, you can, because now you know what you're doing.
Yeah.
So x square minus x minus 1 greater than 0 by x square minus 1, right?
Mm-hmm.
And now it's two factors, one top factor, one bottom factor. Both of them have to be positive together, right?
Yeah.
So the inequality becomes either both are positive or both are negative, right?
Yeah.
Either this is true together or
Or one is, or the top is 0 and bottom is like etc. etc. I guess.
that's
So it can be
fine.
greater than equal, right? So like,
I mean, bottom cannot be 0 ever.
no, I'm talking the top can be 0 and then the bottom denominator can be like whatever because it doesn't matter.
So this is what we have to solve. So how will you solve the first one here? X square minus x minus 1 is greater than 0.
Well, the roots you'll get a complex, I think, for like x squared minus x minus 1 is equal to 0. So
You can say x minus half whole square plus 1 by 4 minus 1 by 4. No, not complex, real roots only.
real roots.
Minus 1
Oh,
by
sorry.
4 minus 1. So minus 5 by 4 this is, right?
Yeah, okay.
So this is coming, I'm just completing the square and writing it like this. So you get x minus half whole square should be greater than equal to 5 by 4. That means x minus half should be greater than equal to either root 5 by 2 or x minus half is less than equal to minus root 5 by 2, right?
Yeah, okay.
So x is greater than half plus root 5 by 2 or x is less than half minus root 5 by 2, right?
Yeah.
That is coming from here, half 1 plus root 5 by 2 or x is less than equal to 1 minus root 5 by 2. And now, since both the conditions have to be true, so here you have x is greater than 1 or x is less than minus 1, right?
Yeah.
And you have to take whatever region is common here. So the best way to do that is to draw the number line and figure out from there. So you have to take both the conditions happening simultaneously. So intersection of these two regions you have to take, right?
Yeah.
So what I will say is 0 is here, let's say 1 is here, minus 1 is here. 1 plus root 5 will be 3.236 divided by 2, which is greater than 1, right?
Yeah.
1 plus root 5 by 2 is somewhere this side. 1 minus root 5 by 2, however, is less than minus 1 because it is minus 1.236 by 2, which is minus 0.6 or something, right?
Yes.
So this is somewhere here, 1 minus root 5 by 2. So from here, the solutions for us are coming like this. So x should be either this side or x should be this side, right? From here, correct?
Yeah.
And from here, the solutions are coming, x should be this side or x should be this side, right?
Yes.
Correct. So
Correct.
common solutions are both should be satisfied. So here the common intersection is this onwards this side, right? And this
Yeah.
point onwards this side, right?
Correct.
Both conditions are fitting. So we are getting x should be greater than 1 plus root 5 by 2, or x is less than equal to minus 1, right?
Yeah.
So that is your solution for the first one. Similarly, you can do the second one also, right?
Yeah.
That same method, you have to do the second one also. Now, from there also, you will get some solution. And then you have to do union of those two, right? Because or, right?
Yeah.
Like whatever comes, like this is what has come here, right? And something different might come here, right? You have to combine both. So that and this, both will be the answer.
Yeah.
So the key thing here is to be able to solve like quadratic inequality. Like if you have something like this, right?
Yeah.
Or how to solve quadratic inequalities, right? So one nice way to solve it is to realize the graph of the quadratic, like depending on the discriminant value b square minus 4ac. If discriminant is less than 0, it is no real roots, right?
Yes.
So if b square is minus 4ac is equal to 0, then the graph will touch the x-axis. And if this is greater than 0, the graph will cut the x-axis at 2 points, right?
Yeah.
And also the sign of A determines whether the graph opens upward like this or opens downward like this,
Right.
right?
Yes.
So given given ABC, we can find out how the graph will look like. And there are 6 possibilities actually. So 2 possibilities here and 3 possibilities here. So if A is greater than 0 and b square minus 4ac is less than 0, then the graph has no connection with no real roots, right?
Yeah.
The graph will look like that. A is greater than 0, D is less than 0, right?
Yeah.
If A is greater than 0 and D is equal to 0, graph will look like this, touching, correct?
Correct.
If the third case is this, A is greater than 0, D is greater than 0, right?
Yes.
And if A is negative, you have one case like this, again one case like this, and one case like this, right? A is
Correct.
negative, A is negative, A is negative. This is D less than 0, this is D equal to 0, this is D greater than 0, right?
Yeah.
So given any quadratic, like suppose this question was there, right? Suppose we have to solve this, right? I will first notice that A is 1. So A is greater than 0, it's an upward graph, right? Then I will say that
Yeah.
if b square minus 4ac is what? 1 minus minus 4. So 1 plus 4, it's 5, right? B square minus 4ac is greater than 0, right?
Yes.
So this graph must be in this case. A is greater than 0, D is greater than. So it must have a thing like this, right?
Yeah.
Correct. And the roots
Correct.
can be easily found. Roots can be found by the formula. So you know these 2 points, right?
Yes.
Once you have the graph here, you know what has to happen for y, which is the whole expression, to be positive. For the whole expression to be positive, you have to be beyond the upper root or below the lower root, right?
Yeah.
Correct.
Yep.
If you are in between the roots, your expression is negative, right?
Yeah, like on the yeah, remember that your if you're between like the like interval, then your inequality becomes negative, but beyond it, then
Hmm.
it's just positive.
So solve quadratic, if there is quadratic expression and some inequality, but good idea would be to try to draw the graph and then figure out from there how to solve it, right?
It's a lengthy question, but yeah.
Hmm. I mean, unless it is easily factorizable. If it is easily factorizable, you don't need to do so much. You can just factorize it and say 2 factors greater than 0 and stuff, right?
But
If
it's
it is
not
a
easily factorizable. So
hmm. So that is the idea. Then which was the
cool.
next one?
But number 9, it's a proof question proves that log 2, 3 is
Hmm.
rational.
Irrational. No?
Rational.
Is
When I got the
irrational.
question, it's a rational.
No, it is not rational. It is irrational.
Okay. Let me change that. Okay.
So try to do a proof by contradiction. That is the standard way to do these rationality, irrationality proofs.
Okay. If we assume log 2,
Hmm.
3,
Hmm.
okay, irrational means it can't be represented as a fraction. Okay. Okay. Log 2, 3 is rational.
Hmm.
That means it can be expressed in the form PQ, P by
P
Q.
by Q. Correct.
Yeah. Okay, well, 2, 3. P by Q. Okay, how do I perform this?
So assume that log 2 by 3, 2, 3 is equal to P by Q, right?
Yeah.
Now
That's a
Now P by Q, P and Q are obviously natural numbers here, and
yeah,
they have no
they
common
can't,
factors.
right, they cannot, they're, yeah, they're natural numbers. Wait, no, they're integers, not natural numbers, because they can be, well, it can't be negative. No, it can't be
In
negative.
this case, it is natural number because this is positive,
Yeah, they can't be negative, you're right, sorry.
right? So now we can say that we have 2 power P by the definition what? 2 power P by Q should be equal to 3, right?
Yeah,
By the definition. So 2 power P should be equal to 3 power Q, right?
yes,
Correct.
yeah,
But
yeah.
is this equation possible for any natural number?
No, because 2 and 3 don't have any common factors.
Right? And another way to say that is saying that this will always be even and this will
And
always
this
be
will
odd.
always be odd, yeah, that makes sense.
So this is a clear contradiction, right?
Well, so it's always irrational.
The contradiction has come because we assume that it can be written as P by Q, right?
Wait, how do you transfer 2 raised to the power P by Q into 3Q into 2P is equal to 3Q?
Whole power Q,
Oh yeah, sorry. Makes sense.
right?
Yep.
Okay. Then the next one was some equation, right?
I just solve for xy. When x squared is equal to 1 plus 6 log,
Hmm.
then y? Okay, log y to the y.
What?
Y squared is,
X
I
square is
don't
equal to
know.
1 plus 6 log 4y.
Yep, 4y. 100. And then y squared is equal to 2x times y plus 2x plus 1.
This,
Yeah,
right?
yeah, that's
Okay.
accurate. The second one is just an exponential equation, and the first one is the real number. I think we should solve the second one first because there's no log involved. So like,
No, you should simplify the first one and remove the log.
okay. Well, the second one is 2. The base is 2 squared, so it will become 3 log 2y.
Why are you looking at second one? Second one is an exponential
No,
equation.
first one.
So first one is x square plus 1 plus 3 log 2y.
Hmm.
How can you remove the log? You can take everything on one side, right? X square minus
Yeah,
1
x
by
squared minus
3
1 is equal to.
is equal to log 2y. So then you have the equation by definition of log, you know y should be equal to 2 power x square minus 1 by 3.
Yes.
So y cube should be equal to 2 power x square minus 1, right?
Mm-hmm.
Correct. So now you have y cube as this, and this is the other equation here, right?
Yeah.
So you have to solve these two equations. So we have y cube is equal to 2 power x square by 2. So 2y cube is equal to 2x square. 2y cube is equal to 2 power x square. This is what we have.
Right.
Okay. So fine.
But then by that logic, what would 2x be
Actually,
equal to?
actually we don't need to do anything. We just need to remove y, no? Just remove
Yeah.
y. Like use this expression for y and put it in this, right?
Yeah.
So you'll get y square will be 2 power 2 by 3 into x square minus 1 is equal to 2 power x into 2 power x square minus 1 by 3 plus 2 power 2x plus 1, right?
Right.
So you're getting 2 power x plus this thing, x
X
plus
squared plus 3x minus 1
square
by
plus
3.
3x minus 1 by 3 plus 2 power 2x plus 1 is equal to 2 power 2x square minus 2 by 3, right?
Right.
Okay. Uh, this is not convenient to solve though, because it's hard. I mean, unless you guess some value, it is hard to solve it, right?
Hmm.
So if I take x is equal to 1, is it fitting? Let's just check some one or two basic values. X is equal to 1, is it fitting? Check. Uh, left hand side becomes 0, so 1, right?
Yeah.
So
2 to the 1 power becomes 1. X squared plus 3x minus 1 by 3 is equal to 1.
that doesn't help because this is becoming 2 plus something, right?
It's 2 to the
Correct.
third power. Yeah, okay, so it just becomes 2 plus 8, which is equal to 10, which doesn't, I mean,
So this is
doesn't
10
really.
and this is 1, right?
Hmm.
So at a some higher value you will have to look at. So
Yeah.
when x is equal to 2, let's say, right?
Yeah.
Then you have 4 plus 6 minus 1. So 10, 9 by 3. So 2 cube plus 2. So 2 power 5, right?
5.
So the 32 plus 8, 40. And this side is becoming, it will be a power of 2. So 2 into 4, 8 minus 2, 6, 2 by 4. 4 and 40, right? It is always 10 times. Some weird thing is happening. 1 second. Why
Maybe
is
we
it
made a miss.
10 times?
Maybe we made a mistake. All of thing.
Clearly, this is not a nice way to do it because you cannot solve exponential equations easily, if at least if there is addition or not, right?
Right. You wait. That thing that you did with the 2y square is equal to 2x squared. Then 2x would be the square root of that, right? So it would become square root of 2y third, and then you can multiply that by y.
Mm-hmm.
So it will become all in terms of y.
We can try that once. We have x square minus 1 is equal to 6 log 4y, and here we have y square is equal to 2 power x into y plus this is 2 power x 2 into 2 power x whole square, right?
Yes.
So what I will do is I will not do all of this. I will solve for 2 power x. Okay, this is a
Yeah.
quadratic in 2 power x, no?
Yeah. Okay, that makes sense.
So it is 2 into 2 power x whole square plus 2 power x into y minus y square is equal to 0, right?
Yes.
So let's solve for 2 power x as a quadratic. So 2 power x should be equal to minus b. So minus y plus minus root over y square minus 4 into a is 2 into c is minus y square, right?
Yes.
By 2 into a, which is 2. You're getting 2 power x is equal to
That's
minus
9y
5
squared.
plus
Like
minus
the under the
3y
square root. Yeah.
by 4. right? So
Yeah.
you get
So
either
it becomes
minus
negative
4y
y
by
or
4 or
2y by 4.
plus 2y by 4. So you're getting either 2 power x is equal to minus y or y by 2, right?
Yeah, okay, that sounds better, much cleaner.
So now you have to use this information in the first equation, right?
Okay, 2x is equal to, let's just say it's y by 2 for now, okay?
Hmm.
Okay, so then the one, so 2x times y becomes y squared by 2. If you take it to the other side, you get y squared by 2 is equal to 2 to the 2x. I mean, 2x squared times 2.
What are you doing? 2x, where are you
2x
putting it?
times y, 2x is equal to y by 2. And then
Uh,
2x times y is equal to y squared by 2.
why are we
Right?
doing that? Why are we going to this equation? We have to do this equation. We have already solved it.
Oh, oh yeah, okay, so.
We use this equation to get this, no?
Right, but 2x is like,
Why will I put it in this?
hmm,
I've gotten it from there. Now you'll get back the same equation again.
but we don't have application of 2x in the first equation.
We have to remove y and solve for x. That's so. I mean, just think about it. If you have used this equation to get this, what will be the point served by putting it back in this?
Wait, okay. Then if 2x is equal to negative y, then the
Or y
first
by 2. If you say 2x is equal to y by 2, we can say that
y is equal to 2x plus 1.
y is equal to 2 power x plus 1. And I
Yeah.
will put that there. So I'll say x square is equal to 1 plus 6 log 4 2 power x plus 1. So this will become x square is equal to 1 plus 6 by 2 multiplied by x plus 1, right? Log
Yeah.
2, 2, right?
Yeah.
So you're getting x square is equal to 1 plus 3x plus 3. So 3x plus 4. So now you can solve it easily. X square minus 3x minus 4 is 0. So x can be 4 or x can be minus 1, right?
Yeah.
So x can be 4 or minus 1 if 2 power x was y by 2, right? So
Now if it's negative y, then the thing becomes negative 2x.
1 second. First solve for y, no. So 2 power 4 is y by 2. You'll get 32. So x is 4, y is 32. And if x is minus 1, this is 1 by 2. So y is 1. These are the two answers that are coming. You should check whether it fits the equation. Put it in the equation and see whether it's coming. Minus 1, 1 fits. 4 and 32, 16 is equal to 1 plus 6 times 4 and 32. We have to see that. If you told x is equal to 4, it is 16 is equal to 1 plus log 6 log 4, 32. This is
That doesn't
5 by
don't
2.
fit.
6 into 5 by 2. So 15 plus 1, 16. Yeah, it fits. Right?
Yeah.
So both of these are correct solutions. It will fit the second equation also. You can check. Now we have to check the other case. Right?
That
Why?
means y is equal to negative 2x.
That is not possible because that means
Yeah.
y is negative 2x is a negative thing. The negative thing you cannot put in the log.
Because the base is 4.
No, because log is not defined for negative things.
Yeah, that's also that.
Not also that, just that. Doesn't matter base was anything.
The,
We said that there are 3 rules of log, no, for log to be defined. What are the 3
okay.
conditions on log to be defined?
Well, the b can't be negative.
B is here negative. If you put y is equal to minus 2 power x, y is definitely negative, no?
Yeah.
So that is wrong. That is not possible. You understand that it has nothing to do with the base 4.
Yeah, it's because it can't be negative.
Yeah, base could have been anything. Still, it will not be undefined.
because it's negative because of the thing that squares. I mean, log is like the exponent, right? So this and so if the square is negative, like what you're trying to find is like b is negative, then it won't
Hmm.
work because squares are all. I mean, powers are always going to be positive or non-negative actually.
Uh, uh, the reason is that any powers, if you are taking positive base, then obviously powers of a positive number cannot be negative,
Yeah,
right?
that's true. Yeah.
So you have to be aware that there are three conditions: b is greater than 0, a is greater than 0, a is not equal to 1. All three conditions must be true at all times, right? So
Right.
obviously we'll reject this because this doesn't make the first equation is not defined. So the only solutions for us will be this and this. So here, notice that
Wait,
first
wait a minute. Wait, log is not defined for negative equations.
log is not defined when the thing here is negative, cannot be 0, cannot be less than 0, has to be
But
greater than 0.
if what if the base is negative, like it's negative two
That's
or
not
something?
defined.
Oh, it's weird.
We have three conditions. No, these are the three conditions. It's not defined because if you define it for a negative base, then things will go wrong. Sometimes it will give positive, sometimes it will give negative, depending on powers being even or odd.
Yeah, okay. So the equation something like log a is like a is negative two and b is negative eight, it won't work.
Won't work, nahi. It's not defined. Log function is not defined.
Oh, okay.
You cannot put negative things in log function. Anywhere you cannot put negative things.
Oh,
Like you have the choice to define a function however you want. Log function does not accept anything negative and it cannot have base equal to 1.
oh,
The
okay.
problems is if you take base is equal to 1, then there is no possibility, there's no output for this because 1 power nothing can give you 2. 1 power what number will give you 2? Nothing. So it's not defined for base 1, it's not defined for negative because signs of the power log will become completely unpredictable if a is negative,
Oh,
because sometimes it can be negative, sometimes it can be positive, depends on the power that you are raising it to, odd, even. So we are not taking any negative inputs, no possibility is there. Or you have to have b greater than 0, a greater than 0, and a is not equal to 1.
okay then.
Are you understanding?
Yeah, I understand that. It can't accept A can't be one, A and B can't be negative
Negative.
because then the log function will become unpredictable and won't work the way that we wanted for our use, I guess. I guess.
Yeah. I mean, uh, the idea is log functions were invented to simplify arithmetic. Why were they
Yeah, but
invented to simplify arithmetic? Because if you have a
hmm?
big multiplication, you can replace with, like, suppose I have to multiply, uh, suppose many terms are there, multiplied by 5.1238, whatever. If I have to multiply this, x is equal to this, I have to do, then what I want to say is this is y, this is z. I don't want to do this multiplication by hand, but what I want to do is simplify this by using log. So how do I simplify this by using log? So we say that this is equal to 10 power something or some base. 10 is my choice of base. It is 10 power z1 and this is equal to 10 power z2, suppose, right?
Yes.
Correct. So if you have a table which tells you what power, any number, what power of 10 it is, right? Like this
Yeah.
is called a log table. So people constructed these log tables where they would find this number in the table 2.513 on any number close to that. And from the table, you can look up and see what value of z it will be. right? Basically, they are
Yeah.
finding the value of Z1, which is log base 10 of 2.513, right? So
Yes.
if they find the Z1 there and look up this number in the log table, and if you find Z2 there, right, then this is just
Yes.
simply 10 power Z1 plus Z2, right?
Yes.
Correct. And now they look up the anti-log table, which actually tells you what is 10 power Z1 plus Z2. 10 power Z1 plus, since now Z1 plus Z2 value, you will just search for this entry. Where is 10 power Z1 plus Z2? What is the answer, right?
Yes.
So the answer X will be obtained by just two lookups. Once you look up to find this log value, once you do look up to find the anti-log, and you are replacing multiplication with addition, right?
Yes.
You are just adding Z1 plus Z2. That is the only operation that you have to do. This was the point in which logarithms were invented or designed, first of all. And here you cannot accept negative inputs and all. It will just ruin everything. Like if you have
So
-2 power something, then you cannot even build a table, because for 1 it is -2, for 2 it is floor. And I don't even know what will happen if it is fractional powers, right?
yeah.
Like it will be totally weird, because even and odd, the signs are alternating, first of all. And if it is fractional powers, what will you say? Right?
Right.
It makes
But
sense to have fractional powers for positive numbers.
the outputs can be negative, like in the case of the fractional, like 1/2,
Yeah,
like
outputs can be log function. Log a b can take any value from -infinity to +infinity. The diagram of the function is like this.
oh wow.
I mean, you know that, right? Log
Yeah. No.
log ax, that, let's say, when x is equal to 1, the function, when x is equal to 1, log ax will be equal to 0.
0.
When x is equal to
That means
a,
y is equal to 0.
when x is equal to a, your function will be equal to 1. This will be
Hmm.
your 1 value when x is equal to a.
Right.
And
Wait.
if you come
Yes.
lower than 1, when x is less than 1 and greater than 0, you will have negative values if your base was greater than 1. If your base was greater than 1, this is the graph. Even if your base is less than 1, if your base is less than 1, actually graph will be like this, right?
Yeah.
Because notice here, if in this greater than 1 case, if x was very large, so near infinity, then log ax, so what power of a do you need to raise it to get a very large number? So you need to get infinity there also, right?
Yep.
So the graph, and the opposite thing, if x was really small, like x was 0.0000, many zeros and 1 or something, what power of a do you need to raise it to bring it to so small value, right? So
Oh
obviously
yeah.
you have to put a negative infinity, because then only you'll get a 1 by a power infinity, something which tends to 0, right?
Correct.
So actually the output of the log function can be anything, -infinity to infinity. But what you have to be careful about is inputs. Like x has to be positive, a should be positive, a should not be 1. These are
Okay,
the
but
3 things.
that doesn't it mean that the log function kind of needs like an update, because if it can't accept the input that's negative, then that's like
No, we only use it for situations where it works. Like it needs an update. You can construct your own log function, correct? But that will not be as I mean, that might solve, like, you have to have a real problem to try to make a new function that solves that problem, right?
yeah, that's true.
Nobody has had any real issues with,
The log function.
like, if you have a physical problem where you need a log function that accepts negative inputs, then maybe yes. But so far, the normal log function is serving us well. There is no need. So people have
No.
not defined anything else. So this much is sufficient. Like all
And
the
one,
applications, all the applications where you need log, your normal log is enough.
yeah, okay.
So
Okay, that was our last question. So is there any homework for this week?
So now,
Because my
uh,
next class is going to be on Saturday because I'm starting school on Monday. So
yeah. So what you should do is, um, like, for the next topic that we'll start is coordinate geometry, where we'll be
okay,
doing
SL only.
straight lines and circles, straight lines, circles. Then we'll go to parabola and all other curves. But
Will
first,
we
we'll
do some SL only? Because I kind of started a little bit. Not I didn't go too far, but
yeah, we are going to do SL only, chapter 4 onwards.
okay.
Chapter 4, chapter 5. Wait, let me just see once.
Okay.
We have to do chapter 4, chapter 4 and 6. Chapter 4, chapter 6. I will tell you what to do in chapter 5. There are some small portions that need to be done in chapter 5, but don't worry about it. If you have time, just do 4 and 6. Okay.
Okay.
So by doing, I mean, try the exercises, see what you can do, what you're getting. Like if there is any problem, just mark it. We'll discuss these things in the next class.
Okay.
So the
We
chapters
still
in
have.
this book that you need to do is 4, 6,
Wait, let me
7,
write it.
8. Yeah. 4,
Okay.
6, 7, 8. Parts of 9. Some parts of 9 that I will tell you when the time comes. Uh,
Okay.
4, 6, 7, 8. Some parts of 9. And then we will do 10, 11, 12, and 13. This is what we'll do. So obviously right now we'll not do it in a lot of detail. We'll do it to the level that you need. Okay. We'll do it till the requirements of your AMC 10, AMC 12 and all.
Yeah. Okay.
This is a little more advanced than your, I mean, much more advanced than your AMC 10, 12, but we will do whatever is required. So, but these are the chapters you can mark. So you should work on 4 and 6 during the week and
Yeah. Okay.
we'll
Um,
discuss that.
I also need some. I mean, theory is fine. Of I obviously need theory, but I also need some good practice questions along with that. So
Good practice
because
questions
I
for what?
coordinate because I don't have a lot of practice in it except for like my usual test. So
Practice for what? Coordinate.
coordinate geo. Yeah.
SL Noni is the best place to practice. Nothing else you need to do.
Okay. Good. Okay.
If you feel like you need more practice, just solve the exercises.
Yeah. Okay.
If exercises are done, after that, you don't need to do anything else.
Okay.
Like it is tougher than whatever you will see in your Olympiads. Okay.
Yeah.
So you will not be able to finish SL Noni.
So how many weeks will coordinate geo take? Because like as as of now, it's like August is like ended only. So that means that September is gonna start and my exams early November. So I only have 2 months left. So I need to like I want to utilize this time I have left for the
There'll
best.
be 3 weeks of coordinate.
Okay.
So if you prepare this part properly and come by next week, then it will be over in next week's class. And then I will give you homework for chapter 7 and 8, chapter 7, 8, 9 and all for the next to next week. And like one week we can do straight lines, pair of straight lines. This is straight lines and pair of straight lines. The next week could be circles, and after that week could be parabola, ellipse, hyperbola.
Okay.
So, but that means that you'll have to actually do it a lot in the week and figure it out. Like if you want to finish it in 3 weeks, then you have to put a lot of effort into it. Then.
That's not a trouble because I'm my problem book that I was doing over the summer. I've almost done it. So like when I started school, my hands will be free because I cover a lot of content this summer. So
Yeah, so then just work on this. In 3 weeks, you can easily finish whatever we need for your exam. Obviously, in 3 weeks, you cannot really finish coordinate geometry, but
yeah, enough
for
for the exam.
yeah. So if you work on it, we can do it in 3 weeks. It's fine. After
Okay.
that, we'll start the other thing, other topics that are there.
Okay then.
Okay, we'll see you then.
Okay, yeah. See you next class.
Bye.